Hello, good day everybody. I am Hume, and today we're going to talk about a topic that causes a lot of problems in the first question in your C-Sec Maths syllabus. This topic is significant figures versus decimal places. Now we realize that I'm considering both of them simultaneously at the same time. Reason being, both of these are often mistaken one for the other. In other words, people confuse them. So you ask somebody for significant figures, they give you decimal places. You ask somebody for decimal places, they give you significant figures. So we're going to look at them both together at the same time, so that you can understand them both by actually seeing the difference between the two. Alright? Now, big tip number one. In any consideration of significant figures versus decimal places, the first thing you need to do, take note of the word first. The first thing you need to do is get the first significant figure or the first decimal place. So the word first is very important when you're dealing with this topic of significant figures versus decimal places, right? First. Alright? So if somebody asks you for two decimal places, you want to find the first decimal place first, and then you count the rest afterwards. If they ask you for two significant figures, you want to find the first significant figure and then you count the rest going afterwards. So, which leads right on into the question now. We have to ask ourselves, what is the first significant figure and what is the first decimal place? Now, listen carefully and note the difference between the two. The first decimal place is pretty straightforward. The first decimal place is simply the first digit after a decimal point. Alright? So for example, if we were to write the number 5.234, then your first decimal place would be the 2. If we were to write the number 0.2869, again your first decimal place would be the 2. If we were to write the number 0.000687, then the first decimal place would be the 0 here. Alright? First decimal place, first place after decimal point. What is your first significant figure? Your first significant figure is, and listen to this carefully now, your first non-zero integer, wherever it happens to be. Right? I'm going to repeat that. Your first significant figure is your first non-zero integer, wherever that non-zero integer happens to be. So, we're going to use these three numbers as examples. In this number 5.234, the first decimal place is 2, whereas the first significant figure is 5. See the difference immediately? Alright? 5 being the first non-zero integer, this will be a first significant figure. Alright? The first decimal point is 2. In this number, 0.2869, this is a case now where the first significant figure will coincide with your first decimal place. Alright? So, because this number here is a 0, this cannot be a first significant figure. Your first significant figure will be the 2 here. Alright? And then do whatever else you have to do. Likewise, it will also be the first decimal place. How about our good friend here? 0.000687. Well, in the case of the decimal place, this 0 here was the first decimal place. But because the first significant figure is the first non-zero integer, then this 0 cannot be the first significant figure. The first significant figure will therefore be our good friend here. 0. Well, after all these zeros, the 6 here would be your first significant figure. Alright? So, first significant figure here, first significant figure here, first significant figure there. Alright? So with just 3 random numbers, you see immediately the difference between the first decimal point and the first significant figure. So I'll say it one more time, just for emphasis purposes. Your first decimal place is your first digit after the decimal point. The 2 here, the 2 here, and the 0 here. On the other hand, your first significant figure would be your first non-zero integer. In other words, the first integer that is not 0, or the first digit that is not 0. So, in this case it will be the 5, clearly. In this case it will be the 2 here, not our friend 0 here. And in this case, the first significant figure, after you go through all these zeros, will be our good friend 6 here. Alright? So that's a little discussion on the first, whatever the first is, first decimal place versus first significant figure. Now, we're going to go into a few examples. Again, we will use the same number in each case and find different numbers of significant figures, different numbers of decimal places. Alright, so let us start with, let me start with 5.234 to begin with. Alright, 5.234. Let us say we want to express that number to one significant figure and to one decimal place. Alright, same value but different quantity. So let's start with decimals because that is what most people are familiar with to begin with. The first decimal place means that we have to find the first, excuse me. We try to find the one decimal place, so we have to find the first place first, right? So the first decimal place would be the first number after the point, which would be here 2. Alright? Now, we know the other part of this, right? But we're going through it still. So then you look at the number after the 2, and in this case the number here is 3. So, if this number is from 0 to 4, then this 2 would remain. If the number is from 5 to 9, we'll change the 2 to a 3. Alright, I think that is the easy part. That is the part that most people are aware of. The part that causes problems would be where we have to find, just to do the transformation, but we have an idea of what to do whenever we find the relevant figure that we're dealing with. So in this case, the relevant figure is the 2, because this is the first decimal place, and because this here is a 3, then 5.234 to one decimal place would actually be 5.2. 5.2 to one decimal place. On the other hand, we now want to consider 5.234 to one significant figure. Note the difference. Because the first significant figure is the first non-zero integer, this here will be our first significant figure, 5. And seeing that the number after the 5 is 2, 2 being less than 5, then this 5 will just remain as 5, so that this will just be 5, that will be one significant figure. Alright, so we deal with a different number again. How about 5.234, this time to 2 significant figures, or 2 decimal places. So we have the same number, but we change from 1 to 2 decimal places as significant figures. So, again we start with decimal places. First decimal place is the 2, second decimal place is the 3. After the 3 I have a 4. So that 5.234 to 2 decimal places would be 5.23 to 2 decimal places. How about 2 significant figures? Alright? The first significant figure is 5. If your first significant figure is 5, then the second significant figure will be 2. And then, having found the second significant figure, you look at the number after it. Number after it is 3. So that 5.23 to 2 significant, 5.234, sorry, to 2 significant figures will be 5.2 to 2 significant figures. Look at the difference. Look at the difference. Alright? 5.234 is 5.23 to 2 decimal places. 5.234 is 5.2 to 2 significant figures. Alright? So I hope that in seeing the difference between the two, you will get a clearer understanding of which is which. Alright? And we could go further with the same number, with this same question. Alright? Well, 5.234 is already expressed as 3 decimal places, right? So we don't have to change anything. This is 3 decimal places already. 3 decimal places. How about if you want 5.234 to 3 significant figures? Then 5.234, the three significant figures will be 5.2, one significant figure, two significant figure, three significant figure. This here will be a third significant figure, and because the number immediately following is a 4, then this 3 will remain, so that 5.234 will actually be equal to 5.23, the three significant figures. So again, you see the difference between decimal places and significant figures. So we're going to change up the game a little bit. Alright? How about if you had 50.869? Alright? 50.869, again, we want to start off 1, 2, and 3. First significant figure, let me express it to one significant figure and one decimal place first to begin with. Alright? So, first decimal place would be an 8. Because the number following the 8 is greater than 5, then we have to change this 8 to a 9. So that 50.869 would be 50.9 to one decimal place. Alright? If we had to express this in significant figures, right? 50.869 to one significant figure, the first significant figure is the 5. And since the number after the 5 is just 0, then watch it now, this will just be 50 to one significant figure. Right? Notice the difference. The answer is not 5, eh? Let me discuss this one time. A lot of students in this case, they will put 5 as the answer to one significant figure. Right? Because they tell us that if it's one significant figure, the answer is supposed to have one digit. No, that is not the truth at all. Whatever your answer is, and take note of this now, big tip number whatever in this video. Whatever your answer is, it must be of the same order of magnitude as the original number. So you're not going to start off with 50.869 as your first number and then get 5 to one significant figure. It doesn't make any sense at all. No sense at all. Right? I'm not saying that to disparage people who would have made that mistake before. Right? But I just throw it out, so that you wouldn't make it again. Right? 50.869 to one significant figure could only be 50. Can't be anything else. Alright? Good. So, 50.869, 50.9 to one decimal place, 50, just 50 to one significant figure. Alright? Because this is a 5 and that is 0. Alright? So let's change the game now to 2. We want to express 50.869 to two decimal places and to two significant figures. Good? So again, we find the first decimal point. The first decimal place is the 8, followed by the second, which will be the 6. And seeing that the number after the 6 is a 9, then this 50.869 will be 50.87 to two decimal places. And similarly, by the same token, 50.869 to two significant figures, we look for the first significant figure, which will be a 5. Second significant figure, which will be the 0. Remember, the 0, once it comes after a non-zero integer, it could be a significant figure. But your first 0, well, if the first figure, in the number is a 0, it can be a significant figure. Right? Don't worry about that part too much, just follow the working, and in the course of the working, you'll pick it up and you'll be able to deal with whatever numbers come to you. And of course, you'll have to supplement it with your own practice, which at some point later down the line, I'll put together a nice little exercise for everybody. But not right now, but later. So, we're going again. First significant figure is the 5. Second significant figure is the 0. What does that mean? It means that since the number following the 0 is an 8, which is greater than 5, we must now change this 0 to a 1. So that 50.869 would simply be 51 to two significant figures. So again, you're getting a sense of the difference between significant figures and decimal places by looking at both of them simultaneously as we go through a range of different numbers of different magnitudes. So we're going to three now. Three significant figures and three decimal places. So just as we did in the case of 1 and 2, we find the first. So the first decimal place would be an 8, followed by a second, followed by a third. So that 50.869 is 50.869 to three decimal places. Right? Three decimal places. And significant figures, the first significant figure is 5, second significant figure is 0, the third significant figure is 8. So, what do? Seeing that the 8 is followed by a 6, which is greater than 5, then this 8 must be changed to a 9. So that 50.869 would evolve to 50.9 to three significant figures. Alright? So again, by comparison, you see the difference between decimal places and significant figures. Alright, so let me take another number. How about, let me switch to some decimals now. Alright, 0.8623, 1. Alright, how many decimal places do you have there? 1, 2, 3, 4, 5. So this number in its original form is given to 5 decimal places. Say we want to round that off to 1 decimal point. Right? For whatever reason, in whatever situation we may find ourselves, we want to round it off to 1 decimal place. So look at what we do. We count the first decimal place, which is 8. 8 followed by a 6 will give you a 9. So this will be 0.9 to 1 decimal place. And by the same token, if we want to find the first, if we want to express 0.86231 to 1 significant figure, same move, we find the first significant figure. First significant figure will be the 8 as well, because the 0 here will not be significant. Alright? Remember, your first significant figure is your first non-zero integer. So that with 8 being your first significant figure, then the number after would follow, the number following it will be 6, which is greater than 5. So that this would also be 0.9 to 1 significant figure. Alright? Now, this is a case where 1 decimal place and 1 significant figure will give you the same value. That is usually not the case. Alright? So don't expect, I don't think most students will have this problem. Somehow we understand that significant figures is a different proposition than decimal places. We understand that intuitively. Right? We have a little problem understanding them sometimes. Sometimes we mix up the two, but we understand that they are different. So that even though in this case you get the same value at the end of the calculation, understand that this is the exception and not the rule. So we proceed. We move from 1 to 2. 0.86231 to 2 decimal places. First decimal place is the 8, second decimal place is the 6. So this could only be 0.86 to 2 decimal places. And by the same token, 0.86231 to 2 significant figures. First significant figure, second significant figure, 0.86, because the 6 is followed by a 2 significant figures. And we could do 3 one time, right? 0.86231 to 3 decimal places will be 0.862. First decimal place, second decimal place, third decimal place. Because the 2 is followed by a 3. And similarly, 0.86231 to 2 significant figures, 3 significant figures, will be first significant figure, second significant figure, third significant figure, followed by a 3. So our final answer will be 0.862 as well. So 3 SF, 3 DP. Alright? And that's basically it. That's basically it. For this number, we could go on and on, 4, 5, 6, going on here. But we won't go past 5 because we have 5 decimal points to start. Alright, now, look at what will happen if I change this number from 0.86231 to 0.086231. You have a horse of a different color. So all we have done here is just divide this number by a factor of 10. So let me just make some more space on the board. Alright, so we have the number 0.086231 and we want to express this to, let us say, one significant figure. Alright? And one decimal place. So 0.086231 to one decimal place. Watch it now. Your first decimal place is 0. That wouldn't change. 0 followed by 8. It means then that we have to add 1 to this 0. So that this would actually end up being 0.1 to one decimal place. And if we want to express this number to one significant figure, your first significant figure will be the 8 here, not the 0, because remember, your first significant figure is your first non-zero integer. Our first non-zero integer here is the 8, so your 8 here will be your first significant figure. Alright? 8 followed by a 6. So because this 6 is greater than 5, we have to change this 8 and 9. So this would be 0.09 to one significant figure. Note the difference. Right? 0.1, 0.09. The confounding factor here is the fact that you had a 0 here in front of the 8, as opposed to just now when we had just 0.86231. In that case, your 8 was both the first significant figure and the first decimal place. In this case, because of the 0, remembering that your 0 cannot be a first significant figure in a number like this, then your 8 would be a first significant figure as opposed to your 0 being your first decimal place. Right? No difference. And similarly, with this same number, if we were to extend the argument to 2, alright, 2 decimal places, first decimal place, second decimal place. Second decimal place is 8, so 8 would be followed by a 6, 6 being greater than 5, so you have 0.09. So 2 decimal places. And 2 significant figures. The first significant figure is your 8, again because of 8 being a first non-zero integer. Second significant figure is a 6, 6 followed by a 2, which will be 0.086. 2 significant figures, right? The 6 will remain because the 2 is less than 5. So again, by direct comparison, compare and contrast if you will, you see the difference between the decimal places and significant figures. So we're gonna, and we can do this going down for 3. Alright, so let me do 3 one time. Alright, knowing that you got the points, but we're gonna explain it still. 3 decimal places. The first decimal place is 0, the second decimal place is 8, the third decimal place is 6. So that your 6 followed by a 2 will give you 0.086 to 3 decimal places and significant figures. First significant figure 8, second significant figure 6, third significant figure 2. So your 2 followed by a 3 will leave you with a 2. So this will be 0.0862 to 3 significant figures. So again, the difference, you can see the difference by direct comparison between decimal places and significant figures. So we're going to do our next number. Change up the order of magnitude a bit and see how it comes up. So sticking with decimals, using this same number here, we're going to put another 0 in front, just to drive home the point. So we have 0.008623, and we want to find that number to one decimal place. One decimal place, the decimal place is 0, followed by another 0, so this will be 0.0 to 1 decimal place. Right? First significant figure would be an 8. And seeing that the 8 is followed by a 6, then this 8 will change to a 9, so you have 0.009 to 1 significant figure. So even though you get 0.0 as the answer here, that is what it is. In this case, clearly, 0.0 wouldn't really be of much use in terms of giving it information. So in a case like this, the more useful thing might be to express the number to significant figures as opposed to decimal places. So it brings into focus now the discussion of different ways of expressing numbers. You have significant figures, you have decimal places, and of course, you have our good friend standard form, which we will cover separately in subsequent videos. Alright, so look out for that. Alright, so that was 1, we go to 2. So, the 2 decimal places, first decimal place is 0, second decimal place is 0, 0 followed by an 8, we change the 0 here to a 1, so you get 0.01. 2 decimal places. And similarly, 2 significant figures, first significant figure is 8, second significant figure is 6. 6 followed by a 2 will remain a 6. So this will be 0.0086 to 2 significant figures. Again, you see the difference between the two, alright, in terms of decimal places and significant figures. So the reason why I'm doing this video like this is to give the viewer a chance to minimize the occurrence of that particular mistake where they mistake one for the other. Right? You ask for significant figures, you give them decimal places. You ask for decimal places, you give them significant figures. So, I will leave, no, we'll do it just for the record. So let us go to 3. 3 decimal places, 3 significant figures. So your first decimal place is 0, second decimal place is 0, third decimal place is 8. 8 followed by a 6 will give you a 9, so that will be 0.009 to 3 decimal places. Significant figures now. First significant figure is 8, second significant figure is 6, third significant figure is 2. 2 followed by a 3 will remain a 2. So this will be 0.00862 to 3 significant figures. Alright? So again, you see the difference between decimal places and significant figures. Alright? So we're going to change up the order of magnitude of the numbers now to further drive home the point of the difference between decimal places and significant figures. So how about if we have a couple more numbers just to drive home the point. Let's say we have the number 968.257, right? 968.257, and we want to express this number to one significant figure, one decimal place. What's the difference? Your first decimal place is your 2. Your 2 followed by a 5 would change to a 3. So that 968.257 to one decimal place will end up being 968.3 as one decimal place. However, in the case of the significant figures, your 9 here will be a first significant figure, being the first non-zero integer, and 9 followed by a 6. This 9 will then change to a 10. So 968 to one significant figure is what? What? 3 seconds. 3, 2, 1. Alright. 968.257 to one significant figure will be 1000. And you leave it there. Remember I said, number you get must be of the same order of magnitude as the original number. So some people might be tempted to change this 9 to 10 and give the answer as 10 or 100. It can't be 10 or 100. Right? The original number is 968.257. So your final answer could never be 10. Could never be 100. Right? It has to be of the same order of magnitude. So it could only be 1,000. It can't be 10,000 either. Alright? So this is one of the areas where you have to bring the intuition to bear. You have to bring your basic common sense then, so to speak, to bear on the situation. Alright? A final answer can't be 10. Alright? And again, I'm not saying this to disparage anybody who made this mistake before. I'm saying this so that you would make it again. Alright? Good. So this is 1,000 to 1 significant figure. How about 2? 2 decimal places, 2 significant figures. Watch it now. Again, your first decimal place is 2. Your second decimal place is 5. 5 followed by a 7 will change to a 6. So that 968.257 will be 968.26 to 2 decimal places. Significant figures now. Your first significant figure, is 9. Second significant figure is a 6. 6 followed by 8 will become a 7. So that 968.257 to 2 significant figures will be 970. And that's it. So again, in every case, the final answer is of the same order of magnitude, right? 2 significant figures, right? Look at there, see the difference, and we're going again. Well, we already have 3 decimal places here, so that if we had to express this to 3 decimal places, it would simply be 968.257, and if we had to express it to 3 significant figures, the first significant figure being a 9, the second significant figure being a 6, the third significant figure being a 8, 8 followed by a 2 would remain 8, so that this would be 968 to 3 significant figures. Alright? So again, you see the difference. Compare and contrast. Decimal places versus significant figures. Okay, so in the final part of this video, just to round off everything, I'm going to use a number that doesn't contain any decimal places. Just a regular integer, a large integer, just to show what happens when we deal with different numbers of significant figures. Because you may get a question somewhere, sometime, where they give you a number and they say express to 1 significant figure, to 2 significant figures, to 3 significant figures, etc., etc., etc. Right? So just to give you an idea of what happens. 862394 to 1 significant figure. 8 is the first significant figure, followed by a 6. 8 followed by a 6 will be a 9. So the answer will be 9000001 significant figure. 2 significant figures. 1, 2. 6 is the second significant figure, followed by a 2. So that the 6 will remain. So you have 8600002 significant figures. Change this back to 8. Alright? 3 significant figures. 1, 2, 3. 2 is the third significant figure. 2 followed by a 3 will remain a 2. So 862000. That will be 3 significant figures. 4 significant figures. 1, 2, 3, 4. 3 is the fourth significant figure. 3 followed by a 9 will become a 4. So you have 862400. That will be 4 significant figures. 5 significant figures. 1, 2, 3, 4, 5. 9 here is a 5th significant figure. 9 followed by a 4 will remain a 9. So your answer will be 390. The 5 significant figures. And then if we want to express it as 6 significant figures, well, that is what we have here already to start with. Alright? So the original number is expressed as 6 significant figures, and we may want to round it off to 1, 2, 3, 4, or 5 significant figures, as the case may be. So I hope that this video would have been of some assistance. I hope that you would have learned something. I hope that you would have seen more clearly the distinction, the difference between decimal places and significant figures. The next step, which I would challenge you to take even before I put something together for you, is to find questions and practice. Alright? Looking at the video, being in a class and understanding is one thing. Practicing on your own so that you can execute these things by yourself under exam pressure is a different matter altogether. Alright? So you have to prepare yourself for that. So you have the video here, you can rewind and look at your own pleasure, but I want to encourage you especially to practice. Alright? Find somebody who could help you work with it. Somebody who could help you with the answer, somebody who you could bounce things off of. Alright, and if you're interested, there's the Algebra Bootcamp, Algebra Clinic, however you want to term it, in July of this year, 2017. Call the number on the screen and you can make arrangements to book and book your place. Alright? Promise you will learn from that and you will firm up the foundations so that you have a springboard, a platform push on everything else in your CSEC maths syllabus and in maths in general. Alright? So enjoy this video and look out for more coming up soon.